Hello, my name is Ken Miller from Panintelligence. I'd like to take this opportunity to take you through a new module that we're just launching called Analytics. Now, Analytics is an add-on to the Panintelligence dashboard, which you'll see in front of you at the moment. And what it allows is us to automatically discover data using machine learning. So if I take an existing dashboard, so this is your very traditional dashboard, and in here I've got some data. Now this data actually really matters because it comes from a radiology department, and it looks at the number of x-rays that are being rejected by a consultant. Obviously, whenever an x-ray gets rejected by a consultant, it's wasted their time, it's wasted the radiologist's time, but also it means that the patient has to have another x-ray, so they're being subjected to a double dose of x-rays, which clinically is very bad for them. So what we want to do here is look and find any patterns within the data, which will allow us to reduce those rejects. Now, in traditional business intelligence, I can go and I can have a look at maybe those rejects by radiographer, maybe see if there's any patterns on things like gender, and I can keep dicing and slicing and chopping and changing the data and exploring it until I find what I believe the most important characteristics are. But actually what we can do is we can use machine learning, and this is where Analytics comes in. Now, the beauty of this is it's targeted at people who work within the businesses, or people with the domain knowledge who can understand, as opposed to the data scientists. We've always found there's a huge disconnect between data scientists, people who are very statistically astute, and people who understand what's actually going on in these different environments. So what we want people with that domain knowledge who understand the data to be able to explore the data in this way very easily. And what you'll see is if you're capable of using the dashboard and creating a chart, then you'll be absolutely capable of using Analytics. So all I have to do that is to come in and select a new chart type, which is Analytics. I go back to my data set, and in this case I'm going to use my radiology data set. The first thing it's asking me for here is a row identifier. So I'm going to use the examination ID as my unique identifier for each row. What I'm then going to do is bring in any characteristics that I think could be significant in the failure of that x-ray. So I'm going to look at the patient's age, the amount of dosage they were given, so how high the x-ray machine was turned up, what sort of examination was done, so we can see, was it a chest or a knee or a cervical x-ray, what the mobility of the patient was, so did they walk in, were they on a wheelchair, what the modality of the x-ray was, so which department that went through. I can look at the projection, so have a look at the different type of x-ray taken. I can bring in the radiographer to see if that's impactful. I can also bring in room, and I can bring in the patient's gender as well, so I can have a look and see whether it's female or male. Finally, the only thing I need to add now is the actual objective, what we want to measure, and this is reject. So up on the top right hand side of the screen here, as I've been building that, it's been giving me a sample of the data, and if I go over to the reject column, I can see it's expressed in this data set as a 0 or a 1. 0 meaning that the x-ray was not rejected, 1 meaning the x-ray was rejected. Now that could be a yes, no, it could be any other type of categorical value, or it could be a numerical value. Anything will do. I'm going to go down here and I'm going to tell the dashboard that reject is my objective. So I select the little lightning strike, and immediately the button becomes active over here to build the model. If I click on build model, this is now doing what a data scientist would do. It's actually deciding exactly what sort of model it can build, depending on the amount of data and the type of data it's got here. But it's going to come back with a statistical tree for me. What I'm going to do quickly is I'm just going to save that. So I'm just going to call that X-ray model and save that. That'll now save and just be presented as a regular part of my dashboard. Now this is what we call a probability tree. And starting at the top, we can follow it down and we can find out exactly what the most significant splits within our data set are. So first of all, I can see that in total in this data set, there's 3,362 examinations. And actually there's a 0.029, which actually means a 29% reject rate within that data set overall. Now as I follow the tree down, this is expressed as what we call a sand key. So the different widths of the lines going between the nodes tells us how many patients end up in each one of these sections. So I can see there's slightly more patients end up in stretcher and wheelchair versus walk-in. And in fact, when I look at the numbers, I can see there's 2,120 patients that came in on a stretcher or wheelchair compared to 1,242 who have walked in. But what I can also see is the dashboard's telling me this is the most significant split it's found. So off those patients coming in on a stretcher or wheelchair, there's a 41% reject rate of their X-ray scans compared to only an 8% reject rate where they're walking in. Now also, if I follow this down, so this looks like a really good subsection because there's only an 8% reject rate, but actually when I follow this down I can see something really interesting immediately underneath that. There's a little box here which says there's an 80% reject rate. Now that's only 35 cases. Now really, from a statistical point of view, that may not be seen as very statistically significant, but actually from a clinical point of view that might be very, very significant. So although there's only 35 x-rays that have been taken of people aged greater than 91 years old, so 90.5 years old, there's actually an 80% reject rate on that. So clinically that might be very, very significant compared to if the patient walked in and was aged less than 90.5 years when the x-ray was taken. There's only a 6% chance that that x-ray would have failed. I can do this down any leg, so following down from stretcher and wheelchair, I can then see that the dosage plays the next most significant split, and I've got again a very high reject rate where the dosage was less than 1.19.195. Now obviously as a statistician that doesn't mean anything to me. I don't know what dosage actually means, but the clinician would know exactly what that means. I can then also follow this down and keep following it down and see exactly how this is made up, all the way down to the lower sets at the bottom, which will show me very high or very low reject rates broken down by the characteristics. This examination and allowing me to see instantly exactly what the most important characteristics are, as somebody with a domain knowledge, not as someone with a statistical knowledge, is so key and so important. And what we found by using these sorts of models is we allow people to make decisions about their data very, very quickly. That's all I wanted to say today. If you would like to find out any more, then please get in touch. Thank you very much.